Okay, now I'm going to do a few examples directly from the textbook. So if you would like more details, please refer to your textbook, section 6.4. Now this is example number 4. Use the inverse sine function to find one solution to sine of theta equals 0.8. So what I would do here on my calculator, let's go with green, would take the sine inverse of 0.8 on my calculator. Now, it does depend on which mode I'm in. So try this on your calculator. If you take the sine inverse of 0.8 and you get 0.927, that means your mode is radians. And if you get 53.130, that means you're in degrees. So be very careful about which one you're in. Now, we've been using radians with pi over 4, pi over 6. All of the ones we've been doing so far have been in radians. You can also, if they're not perfectly fractions on the unit circle, then we need to use the radians such as 0.927. So let's look at this. Remember what radians are, okay? So pi is 3.14 radians. So half of 3.14 is going to be 1 up here, pi over 2, which is 1.57. Is that what that is? Okay, so 0.9 radians is somewhere in quadrant 1. As a matter of fact, we know right where 45 degrees is halfway. So 53 is going to be about right here. And that's going to be 0.927 radians. So you want to kind of practice knowing radians and degrees. Okay. So it says find one solution. Well, we did. And if you're working with you mostly always want to work with radians when you're working with functions and it's not specifically solving for an angle. Okay, so let's go to the next example. This time it says find all the solutions to the same problem, okay? So same problem, only we don't want just one solution, we want all the solutions. So looking at the diagram, here's our 0.929 that we just found up here, or 27, mine said 27. Okay, so here's this one, but we also know that this angle has the same sign as 0.92, the sign is 0.8, of also this angle. So we've got 0.929 radians, which is less than pi over 2, but we also have this one over here. Now, how do we get that? Well, if you think about it, this angle, so inside here is 0.929 radians. Same with over here. We're going to use our reference angle. So this angle, which is what we want right here, is actually going to be pi, take away the 0.929 or 0.927. I'm going to call, I don't know why it says 9 there. That's a typo. It's not a big typo because it's just that, but it really is 0.927. Okay, so we're going to subtract that, and that's going to give us 2.213 about, all right? Okay, so this angle is 0.929 radians, and this big angle is 2.213 radians. Remember, this one is 3.14 radians, so we're looking good. But it says we want all the solutions. So now we have to do the coterminal thing, which is take our answer, 0.929, that's our first answer, and we're going to have to add 2 pi to it. So let's just say, all right, and go around the circle as many times as we can. So 2 pi k. That means negative and positive angles. And the other one would be 2.213. And we're going to also add 2 pi k to that. And those two will give us all of the answers for that, all solutions. Okay? Let's go on to another one. Again, you can follow along in the textbook if you want. So this time, I'm going to find all the solutions where the sine of the angle is -8/9. And this time they're limiting me to, I just want from 0 to 360, which means they're asking for degrees in this case because the interval they're giving me is in degrees. Okay, so you got to kind of pay attention. So first of all, my sine is negative. So I'm not going here and I'm not going here. I'm in the second or the third or the fourth quadrant. So if I do sine inverse of -8/9, my calculator is going to give me, if I'm in degrees, which I want to be, -67.7 degrees. -67.7 degrees is actually not between 0 and 360 degrees. So I need to, and your calculator will always give you the negative because of that, the domain and range of the arc sine and the sine inverse. So all you have to do is add 360 degrees to that, and then you would get 297.3. Okay. Now, that's the one that the calculator gives me. So now I have to use my brain because this one right here is whoops, let's do this correctly. I'm going to write 297.3 degrees. That's this one. Okay. That's right in here. I also need, as you know, that the sine of this angle, which is the reference angle, is 67.7. Okay, so these guys are both 67.7 degrees. But I also need that angle. I need that angle right there to get me, it also has a sine of -8/9. So I'm going to take pi, or sorry, 180, we're in degrees now, 180 degrees, and I'm going to add 67. Do you see this? I'm going to go 180 degrees, but I'm going to add my reference angle to get that angle right here. And that reference angle is 67.7 degrees. And that's going to give me 247.7 degrees. And that is my 247.7 degrees is this angle. So my two answers are going to be 247.7 degrees and 297.7. Is it 247 or 240? Oops, I didn't borrow. Sorry, I subtracted wrong. I have to borrow. And I would get, oh wait, no, I added it. Okay. Okay, and so that's what I get here. They're giving 242 in the book. Let's see, 62. Yeah, there's some misprints in here because it's actually 62.7. You guys probably got, if you're doing this with me on your calculator, it looks like I have an error. If I do sine inverse of, I'm going to just double check this. So if I do second sine of -8/9, it's not 67. I'm so sorry. Okay, so let's just change those 7s to 2s. And that's okay. You know, I promote making errors with my students. And the reason is because everybody does it. Let's just change that to 62.7. So if you're following me along, you're going crazy. No, you're right. Okay. So that actually gives us the the correct, if I add 360 and I subtract this right. Okay, so this actually was the correct answer, but not this one. So let's change that to 62.7. And then that's going to give us 242.7. And that would be the correct answer. Okay, so this answer is 242.7. So that was just mathematical error. I'm sorry for the confusion, but so let's do a summary of this. We found sine inverse to be a negative 62.7 degrees. And this is the typo right there. Sorry about that. Okay, and so that was from the textbook. Apologies. Then, because it's negative, we added 360 degrees to get our angle between 0 and 360, okay? But we also have an angle in quadrant 3 that has the same sign. So we had to go back and look at that using the reference angle, 180 plus our 62.7 degrees. Now, you might think this is complicated. It really helps to draw the picture on these. I'm going to highly recommend that you use a picture. Let's do another one. Okay, so this one is find all solutions on 0 to 2 pi. That means I need radians. Okay, that's your ticket right there. If they ask you, okay, if it's in degrees, you give them degrees. If it's in radians, you give them radians. Okay, so I'm going to start by doing tan inverse of 3. So if you do second tan on your calculator, do it with me to see. And by the way, change your mode to radians. That's the first thing, because I was just in degrees. So if we do tan inverse of 3, you should get, looks like it's 1.2. Oh, they did this one right. This one is 1.249. And that's in radians. Okay, so that's this angle. All right. Now, the tangent has a period of pi, and that's why you see this on your circle. So every pi, I will get another tangent that has the same. This is a positive tangent, so this, and we'll go back and forth. So we want from 0 to 2 pi means there's only 2 of them, because the next time I go around the circle will be greater than 2 pi. So all I need to do is take my 1.29 and add 3.14 because I'm in radians, and that will give me the 4. Let's add this one correctly. Okay, so 3.14 plus 1.249 gives me 4.389, which again, they're a little bit off on their circle here in the textbook, but remember these are free textbooks, so we don't complain too much. Okay, so we have 2 answers, and the first one is 1.249 and the other one is 4.389. They have 9.1. I'm guessing that's a round off error. Okay. All right, and I think there's one more. So this one has a little more. You just have to get the angle by itself. So let's take a peek right here. We're doing radians again, so keep your calculator in radians. We're going to find all solutions from 0 to 2 pi. So let's subtract the 4, and we'll get 3 cosine of t equals -2. Divide by 3, and we'll get cosine of t is -2/3. All right, now the cosine is negative, so we don't want it here, we don't want it here. We're going to be looking at quadrants 2 and 3. So let's do cosine inverse of -2/3. And so we're in radians. So second cosine of -2/3 gives us 2.301. So looks like the textbook's good there. So we get 2.301. Now we also know that's this angle right here. Okay. We also know that the same cosine is down here. And so what we need to do is figure out what that angle is. So the textbook is showing us, well, let's just take the reflex angle and go negative 2.301, which is the negative angle of the same one. So let's go for that. So let's see, so the whole, so I'm back on the picture over here. So if this is negative 2.301, then the whole negative 2.301 is also the angle I want. And if I add, to make that positive, I need to add 2 pi to it, right? Because we want a coterminal angle that's positive. So I'm going to say 6.28, that's 2 pi, plus negative 2.301. So if I do 6.28, 2.301, that gives me, that's 3.98. I'm going to round that off to 3.98. Okay. So my two answers are this angle, which is 2.3, and this angle, which is 3.98. Okay, so let me review how we got that. First of all, we found the cosine was negative, so we're in quadrants 2 or 3. And then we found the radian measure of the angle that gets us that, which turned out to be 2.301. Okay, so that was this angle. And then we know that if we went negative 2.301, we would get the same angle. So if we just add 6.28 to negative 2.301, that will give us the correct angle between 0 and 2 pi. Okay, so that's going to end this video. Go ahead and try the my open math for section 6.4, and then we'll discuss more of this in class as well. We'll get lots of practice in class. Actually, you have 7.1 to do, which will help you practice solving more equations. Okay.